I'm sure as Java developers, we have all worked heavily with design patterns and with data structures and algorithms. The fun part is now when you are becoming AI engineer and trying to integrate AI into your systems, all of those concepts are not going anywhere. Because as you will see today, that builder design pattern is still relevant and it works under the hood when you are trying to integrate memory and RAG while you're building production ready AI agents. Or did you know that sliding window algorithm is being used under the hood when you are integrating or adding memory to your AI agents? So, welcome everyone to this series that we have started on AI engineering for Java developers. These are the videos that we have already covered. Now, the reason why this series is so very important if you're building production ready AI agents is this video series coupled with the blogs that I'm sharing on Medium. Both of them together are going to help you build systems thinking for production AI agents. Like I've mentioned over here, this is not about getting to a working code by integrating memory, RAG, tools, MCP, and just getting to a working code in minutes. It's more about the question, the way we as Java developers learn. We like to understand what is working behind the scenes, what is working under the hood. Like when I started digging into the libraries, I came to know that this is the algorithm that is being used, the sliding window algorithm. So as Java developers, it is very important for us to question and then to understand what is working and why is it working. Only then we'll be able to make the integration that can actually scale with time. So as part of this series, the highlight is you're going to learn about the engineering fundamentals are not going anywhere. They're still relevant. And now you're going to use more of those fundamentals that you have learned, be it system design, be it DSA, and use and leverage more of that while you're building production ready AI agents. So that is why I say that this series is more about systems thinking for production ready AI agents. So with that being said, we have in the very first video, like the episode 0, we recently published this and we learned about how do we architect an AI agent. Continuing from that, we will today learn about memory and RAG. Again, not just getting to a working code, we are going to see the underlying libraries, classes of Spring AI and what is working, how the implementations are being done, what is the interface that is there, what is the role and responsibility of every library, so that when you have to do any customization for your workloads, you will be able to understand where exactly you need to tweak. So please refer to these blogs also so that you have all the textual content available. So with that being said, let's dive right in. So a quick recap of what we had done last time. We had added these two dependencies, the starter web and the bedrock converse. So we did a quick comparison of all the three types. Using Docker, we created the AI agent, then using Olama, and then we also created using Amazon Bedrock. So in the POM.xml, we had added these dependencies, and in the application properties, we added the necessary properties for the access key, secret key, and also the model that we are using. Now, in the previous video, what we also did is in the controller, I've just commented out that particular code. In the controller, we just wrote a get mapping and we had this particular chat client and then we sent the prompt and the .call.content. Now, as part of this video, what I want to showcase is, imagine, let me just run the server and I'll go to and I'll ask and interact with my agent. Hello, who are you? Just notice how the response is getting generated. It is coming as and when the tokens are being emitted, as and when it is generated, it is being emitted to the user, to the client. So this is creating a better user experience rather than you are waiting for the entire LLM to generate the response and then send it to you, which will create a higher perceived latency. So nowadays, when you're designing AI agents, how you're getting the response also matters. So this particular code, if this was running, okay, so let me just comment it out. And so this particular code is now under a new endpoint, which is the chat sync. So what is the difference? Let me show it to you on the Postman. So this is the streaming endpoint, similar to what we just saw. So when I'm hitting this, you are getting server sent events or the SCCs that is getting generated like this. However, if I hit the non-streaming endpoint, which is over here, you are going to get that entire response as a string. So on Postman, the difference is not, it's quite negligible, but when you have seen it on the UI, as we can understand that latency is a very important thing. Even when you interact with other AI agents and AI assistants also, you will be able to see that the response when it is streamed, it gives us a better UX. So now we know that, but how do we actually implement that using Spring AI, using our Java code is what we are going to cover over here. So for that, couple of things. First, we are done with the pom.xml and the application properties. These two things we have to do. Okay, you are also seeing the UI here. So from this playlist that we are the series onwards, we will be using this web UI. So there's some static resources that I have. Feel free to design the UI as you want. I've just created a very basic vanilla JavaScript and HTML CSS. So that is the thing around the UI. Now we created a chat service client also. So earlier we were just hitting our controller and then adding the chat client. So now we are creating a clean, simple service class. I just want to show one more thing, that this chat client interface, it is very important for you to understand. A chat client interface is the main entry point for interacting with the AI models. So it will give you the unified API, and it will support these two methods, the call.content and stream.content, and it is using the builder pattern that we have seen also earlier. So because of that, let me also go into the class. Feel free to explore on your end. This is the chat client interface. You see there are two things. One is this interface, what it is interacting with. Okay, the implementation is this default chat client. Okay, and underlying it is actually interacting with the chat model, which has the actual call method in which it is taking the prompt, generating the output, all of that. So we don't have to technically work with the chat model. This is the lower level building block. We have this chat client interface as an abstraction on top of it. So we are going to interact with this, which exposes the builder pattern, which exposes the streaming and non-streaming response for that the respective methods. So gives you a unified interface or an abstraction to interact with. So that is why very important for you, your first entry point or your starting point has to be all the interactions has to go or happen with this particular interface. So this is the service class. Now we have two methods to demonstrate the difference between streaming and the non-streaming response. So the basic construct remains the same. You have this chat client, and then you are using the builder pattern, adding the prompt and the user prompt, stream and content for streaming and call.content for non-streaming. And then of course you have your controller. So over here, one key thing to notice is when we are using the streaming endpoint, we are of course using a post mapping for that, and we are having a different endpoint value. What it produces is this particular media type, text, event, stream value. And these are all the different media types that you have available. We have something which we work as Spring Boot developers, we know this. So when you're using this, you're going to use this particular media type, and everything else remains the same. It's just that instead of you typing chat client and that entire method, you just have to call the service class and pass in your prompt that you're getting in from your request parameter. And over here, the username and the authorization is turned off because we have not yet added security to it. This is optional. Feel free to omit if you do not want that in the initial development stage. But this is the overall structure of what it is going to be. So in this way, you can try out in writing your own controller and see the difference, as we have seen from the Postman and also from the UI, on what happens when you are using two types, or rather two different methods, the dot call content and then the dot stream content, and then interact with the AI agent accordingly. So this is like the very basic starting point. So now we will move on, and we will continue with the rest of the demos. So next we are going to talk about persona or the system prompt. We know system prompt, what it is, but why do we even need it? So when I'm writing this particular message, hello, how are you? It is just saying what the underlying base model is. But in reality, like when you're doing it for your own use case, your own business context, you would not want this kind of a response your agent giving to you, right? So that is where your system prompt comes in. So system prompt will define the AI agent's persona, behavior, and the constraint, and it is going to be sent with every request. So it is going to actually define how your model is going to respond. And these are the things that will set the boundaries, set the context, specify the tone. Because when you are deploying your agent for your certain business use case, you would want the agent to actually be in tune with that particular business context. So in Spring AI, we configure the system prompt again using the builder pattern. So we have a method like default system. Okay, so now let's implement that particular in our code. So what we will do is, in the chat service client, we are just going to copy this particular system prompt. So over here for this particular demo, we are using this like a fictional unicorn rentals company. Feel free to define any business context that you want. So we'll go here and we'll just define the system prompt. Once we have done that, very simply, we'll just have to copy this and put it in our builder. that this is the default system prompt. So in this way, your bean, your chat client bean, every time you are interacting with this particular service, this bean or this particular service or rather your class, so this particular bean in the context of this entire conversation is always going to have this default system prompt. But if you want to override this, right? So if you have to override this particular system prompt, you'll have to do it in a customized way when you are using the chat controller. Or rather, you can do it in this way also. When you pass in system, you can override the system message over here, and then you can, instead of this particular prompt, you can pass in your system prompt additionally or differently. So basically, if you define your system prompt, now when I'm going to ask the same question, it is supposed to reply according to what I have defined in the unicorn rentals context. So let the server get started. Now I'm going to go here, just copy this message. So you see that here now we are getting the response in context of my business requirement. So now while I interact with the agent, I'll just mention my name. And I'm going to ask again, who am I? So you see that although it is giving me the answer in the correct context, but it is not able to hold conversation with me by retaining who am I. Why does this happen? Because the underlying models are stateless in nature. All the AI models are going to be stateless. It will not have any knowledge of the previous interaction unless you append that in the prompt that you're giving. So if you want to create conversational experiences, we have to ensure that the application has to manage the conversation history and include that with the request. Now, Spring AI provides you the MessageChatMemoryAdvisor to handle this automatically. So you do not have to actually do the heavy lifting of storing or other, managing that memory layer where you are going to store the experiences. So you do not have to do the heavy lifting of storing in the memory or writing any boilerplate code for doing that. This MessageChatMemoryAdvisor will intercept the request also. It will retrieve the conversation history and append to the prompt. So when it appends to the prompt, like I said, there are two types, right? One is the system prompt that you're giving, and then there is the user prompt, which is your prompt. That is what you're writing over here. And what response you're getting, this is the response from the assistant response. Now, when you are actually having the conversation here, when I said, hello, I'm Varsha, it gave me a reply. Great. But next time when I'm giving this prompt, so what it is actually receiving is it is receiving who am I as the user prompt. Along with that, it is also receiving the previous system prompt which we had given, that defining the unicorn rentals, this thing. Nothing else. So it is actually the reason why it is not able to recall who am I is because in this prompt, I am not supplying with it any context about my name. So that is why it is not able to reply. And it is not having access to the previous conversation history. So first we have to understand why the memory is not being retained, and then what can we do about it. So we do not have to manage anything for that. We simply have to use this particular advisor. Now, quick note, couple of storage options you have to take into consideration when you are building this for your production workloads. So first, for POC local testing, you can use the in-memory chat memory repository. The only thing is it will get the data or the context gets lost on every time you are restarting the server. However, for persistence, you would need to have either relational or non-relational databases, for which we have all these options. So for this demo, we are going to use JDBC chat memory repository. We will use a H2 database, and the file storage mechanism we will use. So accordingly, based on your business requirement, feel free to use any of the repository. Remember, whenever we are using any kind of a JDBC repository or any repository interface like this, we don't have to write the boilerplate code. We don't have to write the CRUD business logic as well. So similar to that, on that particular design principles only this has been made. So you have the advisor, you have the repository which has the underlying methods also. All you need to do is to plug these things together. So now let's go to the code, and one by one, let's understand what are the things we need to do there. So first of all, we'll go to the pom.xml. Pay attention to what we are actually writing in the dependency. So here, very simply, we have a dependency of the H2 database like we usually do when we are working with JDBC memory repository. Now, in this case, we have a different artifact, which is Spring AI Starter Model Chat Memory Repository JDBC. So these two are the pom.xml changes. Next, in the properties, couple of things which you have to take care of. So we had the last property over here, this bedrock converse. Apart from that, Some things will remain the same, like when we are configuring the JDBC's data source, we have the username, password, the URL that we have, the H2 console we are enabling so that we can view the records that is getting stored in the database, and also the now, what the new thing that has been added is these two properties, which is having a prefix of Spring AI chat memory repository, and then JDBC initialize the schema and JDBC schema. Now, this particular schema file that we are creating, schema h2db SQL. Okay, so now this particular SQL file we have to create it on over here, right here. Now, how will you get the schema file, and what is actually going to happen if you do not include the schema file? So we will also see that. And I'm just telling the steps what we need to do is the pom.xml we added, application properties we added, and here in the schemas, the SQL file, we are creating a simple table, the Spring AI chat memory. I'm going to show you where did we get this SQL from. This table will have the conversation ID, like it can be conversation ID is something which is tied to like your session ID of the user who is logged in, the content, the type. When we are going to store the memory, store this interaction in the memory, we will see and query these tables to see what does it contain. And then yeah, these are the particular table index that we have created, and we have also added the constraint of in the type check over here. What is the type of the message? The user message, or is it assistant, system, or tool message? So this is a basic thing that we have done. Now we have been using the controller and the chat service so far. I just separated this into a chat client config in which we created this configuration, we annotated with @ configuration, we have the system from. Now we created a simple bean over here, which is the chat client bean. To this, first, we are creating this variable called the chat memory repository. I have done this import of this from the new dependency that we added. We'll also pass in the data source bean over here. Very simple bean configuration like we do. Now, two things. One, we configured the memory repository. Now we also have something called the chat memory. Okay, this is the message window chat memory. You can also check this class, which is the chat memory. So this is the interface, the chat memory, which has the conversation ID. Okay, this chat memory conversation ID. And if you read through this, you will be able to see all the methods, like the add method, to which it is going to add the list of messages tied to your conversation ID. Okay, so this is the contract for storing and managing the memory, that basic building block. This interface is being implemented by the message window chat memory, where we are using sliding window algorithm, in which we will have a default max messages of 20. So what is going to happen is it has a message window of this much size, and ensuring that total number of messages do not exceed that limit. If it does, older messages get affected. And again, in order to understand what this class does, must read this add method, where you are going to see that in the memory repository, that particular bean that we have, we are first checking against that conversation ID, do we have any list of messages? This is how we are retrieving the messages. And then we are also having a process method, which is just going to process it. Not going into each of these methods, very interesting to read the Spring AI implementations, what is giving us the mechanism of dealing with this. So it's very interesting to read that. So basically, we are creating this memory repository, adding our data source, which is going to be auto-configured. Then we have the chat memory, passing the repository, passing the max messages here also. Feel free to tweak that. And then the builder pattern that we're using for building our chat client bean. To this, we are also adding an advisor, in which we are now using that MessageChatMemoryAdvisor. Open this, it has a base chat memory advisor. Now this particular advisor, what it is going to do is, it is going to pass in this particular bean where you have the memory repository. So this chat memory particularly is now being passed. So in your advisors, this is how we are going to pass this. And now my chat client bean is now ready with all the memory related configuration. Now simply what I have to do is over here, if you see, we didn't have this particular line before. So now what we have to do is, in the service class, when we are actually prompting to the user, prompting to the model. So in this advisor, what we are actually writing is, ensure that whatever my request ID or my username, session ID, whatever is being coming, to that we are going to add this parameter of the conversation ID. Where did we see this conversation ID? We saw this conversation ID over here inside the message window chat memory. And yeah, so over here, right? Okay, no, I think in the interface, sorry. So in this is the key. So it's a key value pair. So it's like just as we store in our hash map. So against, if you want to have unique interaction per user, so that is why it is important to pass in the conversation ID, which will take this as the default value. But of course, we want to have different keys for different users. So that is why we are overriding that in this particular service class. So we're passing in the conversation ID and the username. Okay, so far so good. And in the controller, we don't have anything else to change. So these are the things that we are going to these are the changes that we are going to do. Okay, quick thing on this SQL file. So how did we get this is, I'll just go to the JDBC particular package over here. Inside this, so this one, the Spring AI model chat memory repository JDBC. Over here, if you scroll down, we have all the dialects, and here we have the different SQL files. So what was happening is, like, you can see that for Postgres, MariaDB, we have the SQL files defined. So ideally, because of the auto configuration, it should. But when I'm adding the H2 database separately in the pom.xml, it was saying that there is no schema which exists. So if you do not add manually this particular SQL file and do not configure the same through this particular application properties, you may not be able to store that conversation memory in the H2 database. So that is the reason why we have to add. Second thing which I want to say is, here the Spring data source URL, it has like two types of chat memory. One, this is like the one which is commented out on line number 13. This is a file based storage. So if you restart your server, it is still going to persist. But if you use this one, it may not persist. So we are going to use the file based storage over here, which is this. So I think we have uncommented most of the changes and we should be good to go now. So let me restart the server. Yeah, a couple of things to check in the logs, that the connection URL is added over here, like you can see here. And the H2 console is now available at this particular path, which we will check once we have hit. And the Bedrock, the application has started. So now let's go to our agent. And I'm going to do the same thing. Let me ask the same question again. Right, so now it is able to hold this particular context. So let me also go to the H2 console. It is 8081. And over here, I'm going to change the JDBC URL, which I'll pick from here. Great. So now we can see this particular table. Let me query this, and this is what you're going to see. So in the previous test, I had done it with a different session ID. Now I am logged into the CI agent. This is the new user I'm logged into, and so as you can see, this is the message which is coming, the conversation ID and the content. This is this particular table. Oh, so this is the conversation ID is this, content is this, scrolling right, as you can see, this is a user message. Okay, so this is the user prompt, and this is the response what I'm getting, assistant message. Again, the same. So this is how you can actually verify where the messages are getting stored in what format. And this is a very simple example of how you can do it. But in real time, in real production cases, you will have a lot of different more checks, constraints, and nuances to take care of. So now to this AI agent, it's a rental service, right? So now I want to ask to the agent about what are the available rental packages. So I'll ask what are the available rental packages. So as you can see, the agent doesn't have access to any current rental packages. So this is more like the proprietary information that is very specific to your particular business domain, which it doesn't have access to. And that is what brings us to the concept of RAG, or retrieval augmented generation. So your response that you're getting, the model is being trained on some data earlier. Okay. But why do we use RAG is because the model has a training cutoff that particular date. And secondly, it doesn't have access to your proprietary documents. So when you're using RAG, or retrieval augmented generation, this is the process of giving your LLM access to external up-to-date knowledge sources before it generates the response, so that it will answer with your own data, your own company data, your own proprietary data, and not the data it has been trained on, right? So unicorn rental service that we are building, it's a very fictitious service that we are building, which is very core to your particular business, let's say, and it will not have access to your sort of data. So let's say this is the sample PDF that I have, in which we have just created some rental packages, and then how to handle the unicorns, the booking policy. This is very core company data, which it will not have access to. So that is the reason we are using RAG. So remember that LLMs are trained on the static data which has a cutoff date, and if you do not give it the appropriate external data source, it is going to hallucinate because it doesn't know the answer, and it doesn't know the answer because it doesn't have access to your proprietary information. So RAG is solving this by retrieving the relevant information from your particular knowledge base and injecting that to the prompt. How it works is this is the flow that company related sort of this PDF, for example, this will be split into chunks, converted into vector embeddings. Vector embeddings are nothing but the numerical representation of the data. Now those embeddings have to be stored in vector database. So how RAG and vector databases are connected is because RAG is the process, but in order to achieve that particular document are going to be chunked and the embeddings are generated. Those embeddings are stored in the vector databases. So what happens now when you are going to ask the question to the particular agent, which is using the LLM underneath, now when it is going to answer it, it is going to refer to the existing embeddings which are stored in the vector databases. It is also going to convert your particular prompt into necessary embeddings and use a similarity search to fetch that top K document. So top K is also a parameter that we will talk about. So it will relevant. So in simplest sense, it is retrieving the most relevant documents that it can retrieve from that particular data store. And then those retrieved chunks are added to the prompt that this is the context. Okay, these are the documents that you have to refer to, or rather these are the chunks which you have to refer to, or rather these are the contextual information you have to refer to, and then the model can give the response. So very basic level, under the hood, this is what is happening when we talk of the RAG flow. Now for Spring AI, you have another advisor which is called a question and answer advisor, which is going to handle this automatically, like the embedding model choosing, chunking strategy. Yes, you have to set up the vector database on your own, but it is going to intercept the request, perform that particular similarity search that you have to do over here, comparison of that, and then augment the prompt. So you don't have to write a single line of code for this. But if you're not using this advisor, there's a lot of boilerplate code which you have to write, which you can of course also write to customize the logic, but this is what you have to do. Now for vector storage, Spring AI will support multiple backends. If you go to the documentation on the left hand side, as you can see, these are all the supported vector databases that we have. Now building RAG from scratch will mean that you have to choose the embedding model, you have to implement the chunking strategy, you have to set up the vector database. Now database, as we know, the data has to be synced, then you have to handle the updates also. So it's a lot of infrastructure before you write your actual business logic. So that is why for the scope of this particular demo, we are going to use Amazon Bedrock knowledge base, because the entire RAG workflow end to end is being handled. There's no custom integration needed. There's no infrastructure management needed. So if you are anyway running your workloads over here on AWS, or if you want to have a fully managed end-to-end RAG service, then you can use Amazon Bedrock knowledge base. And it will take hardly 5 minutes to set up the knowledge base and do the data sync also. So this particular PDF that I've just shown to you, I'm going to upload this to this particular Bedrock knowledge base. Now, what are prerequisites? Of course, your AWS account you need, the Bedrock access enabled, which you would have anyway done if you are following along from the start, and the data source you will have to sync. So once that is done, then we will go to the code and start with this dependency, adding that in the pom.xml. But let's first add to the knowledge base that particular PDF. So we are into the console. This is the Bedrock knowledge base. So one cool thing is, without even writing your code, you can still test the document that you are uploading or the knowledge base that you are creating. You can also chat with that. Just have to select the model, upload your data, okay, set up some guardrails, and then you can test it also. So this way you can chat with your document just to understand if you are getting the right information, or as we are doing it programmatically. So this is how it will work. So you can create the knowledge base by uploading it, then you can test and integrate. So we'll click on create. Knowledge base details you can just give any name over here. We'll use an existing role for this. Now there are a couple of data source. Preferred option is S3. So Amazon S3 we can use, in which we can upload our document. Otherwise, if you want to get your data from Salesforce or from SharePoint, Confluence, web crawler, or any custom data source, you can ingest your data from any of these places also. So for my this particular demo, I'm going to use Amazon S3. And then over here, we are going to upload to our S3 bucket that particular PDF. A couple of parsing strategy. If now there's a PDF, so I'm going to use the second option. So it will allow you to parse the text and store the multimodal content as text. Now, if you just want to, let's say, put any simple text document or HTML file, you can try with this default parser. And you can also choose the chunking strategy based on your business requirement. So all of this are like optional. You can go with the default option. So we are going to go with the default option. So I'm just going to upload to the S3 that particular document. So I've already uploaded this particular PDF on the S3 location. You can just click here and you can view this as well. Over here, this is the S3 URI. Now, coming back to this parsing strategy, I'm going to select the second one. Click on next. Now here you can select your embedding models. Remember, your embeddings, your documents are going to be chunked, converted into embeddings. So over here, I will use the Titan embeddings G1. Again, depending on what is your requirement, choose the model accordingly. Now here in the vector store creation, so remember the embeddings, for the embeddings that we are going to create out of the database, the documents get chunked. So let me revisit here. Documents get chunked, converted to embeddings. Embeddings are stored in the vector database. Your PDF is not going to be stored in the PDF, is not going to be stored into the vector database. So for here, for this reason, you can use an existing vector store. Let's say these are all the options that you have, or you're going to create a new vector store. So for this demo purpose, we will use Amazon S3 vectors because it is cost effective, it has durable storage, and also most importantly for the sub-second query performance, it will be relatively faster. You have other options as well. So once we are done with this, we can click on next, review it, and we'll click on create knowledge base. So once the knowledge base gets created, then we are going to just ensure that the data is synced, and we are going to take a note of the knowledge base ID, which we are going to use. So now going back to the documentation, first thing which we have to do while the knowledge base gets created is we need to use this particular dependency. Okay, so we'll just be here. So as you can see, the knowledge base is getting created, status is available. Now, one important thing is once you click over here, you have to also sync this. Otherwise, if the data is not synced, then it is of no use, even if you use this particular knowledge base ID. Okay, so you have to ensure it is synced. You can also click on test knowledge base to interact, like chat with the document like we had shown before. Now going back to the code. So first is this particular knowledge base dependency that we have to add. Secondly, since we will use the question answer advisor, which is in this particular package, Spring AI advisors and then vector store. So these are the two dependencies which you have to add in your particular pom.xml. So now we have just covered the dependency that we had to add. Now in the application property, these are the two properties which you can add. One is the knowledge base ID, which we have just generated here, this particular ID. And second is the region, or you can use environment variable for your production workloads. Now, what are the code changes you have to do? So we have to create this bean so that we can auto-wire the vector store over here. So we'll create the bean over here like this, that these are the particular, what is the query, but the query is something which you are anyway going to get from the prompt. So we'll just customize this bean creation. Now every single configuration property is very important. So we know about the knowledge base ID and the region. When we talk of top key, how many results, how many closest match result, or how many relevant results you want to return. So this top key value can be provided as a configuration property also, or I'm going to show you, like when I'm creating the bean over there also, I can pass it as part of the builder pattern. Same for the similarity threshold. You have to understand what is, see, anything in middle, like the midpoint 5 or 0.5 is a good number so that it is giving us a balanced result. Then the type, like semantic or hybrid. So when we say semantic search, it should be like when I'm talking about what is the price of this. So it should take into consideration wherever it is written cost or numbers or dollars or rupees. So these things it will understand what is related to the prompt's question around cost or price. So that search type you have to specify. And yeah, that's it. Now, Bedrock knowledge base will support two types of search, semantic and hybrid. Now, hybrid is only available in open source based vector store. However, with S3 Vector, the one which we created, will only support semantic search. So hybrid is more like semantic plus the keyword search. So we can also mention that search type. And with that, let's now check the config class. So over here, what we have done is first define this bean, the vector store bean, like I mentioned. We're going to pass in the knowledge base ID here. So I'll copy this, I'll paste. top K, similarity threshold, and search type is also passed. Next is I will also create a bean for this Bedrock runtime agent, Bedrock agent runtime client. Okay. Now this particular client is going to be used to query the knowledge base. How and where am I going to use this particular client is over here. So you see when I'm creating this particular bean for the vector store, I'm passing in this client as well. Okay, because it has to look for in what region. So this is very similar to two ways. One is you pass it in the application properties, or when you're anyway customizing it from the bean, you can pass it over here also. So this is the client that we are passing. This is the vector store bean we are creating. Next is this particular line number 92, 93, and 94. Look at these three lines. So over here, what we are doing, we're using the question answer advisor. So in addition to memory, message chat memory advisor, now there's a new advisor. To this, we are going to pass in this particular vector store. Okay. And then in the search request, remember the search request builder that we have just seen. Now we are passing in this particular top K as well. Now this is something which is not necessary to pass. It will work irrespective of this. So now we will just comment out all the necessary, uncomment rather, all the necessary changes. So we have the vector store over here. I've commented this particular line because it's redundant. We don't need it. So we are all set. Now let's restart the server and now interact. So now we are expecting that when we are going to ask about the rental packages, it is supposed to give us the right answer, which is going to be based or rounded from the PDF that we have uploaded. Yes, so now we got all the packages like exactly we had in this particular PDF. So now it is able to refer to my PDF that we have uploaded on the knowledge base, chunked it and indexed it, and now the data is also synced and it is referring to those packages. So you can ask anything from that particular PDF, it should be able to answer. So that is the whole point of being able to achieve RAG functionality using Spring AI code. So as we wrap up the video, so a quick recap on what are the things that we did for adding the RAG functionality. We added these dependencies, we created the vector store bean with all the related parameters that we just covered, and third step, so just three simple steps, we wired this particular question answer advisor into the chat client. That's it. So all of that is anyway available on this. So make sure you read the blog and take the notes from there. So quick recap, what are the things that we covered? We covered all of these classes: chat memory repository, message window chat memory, the memory related advisors, which one when you should use. Again, a detailed breakdown of that is available on the blog. We understood how RAG, why do we even need RAG, and then how do we integrate RAG into our particular application, and then the available vector store, and why we are using Amazon Bedrock knowledge bases for this, and the implementation finally of the RAG. Okay. And so these are the architectural patterns which you need to understand when you are going to build production ready AI agents. Upcoming next video will be about tools. So upcoming is going to be about integrating tools, about accessing real-time data, because currently LLMs, your models will not be able to do so. So deeper dive on that is going to be the next video. So stay tuned to this series. Please subscribe to the channel if you haven't already, and like this video if you got some value out of it. Do share it with your fellow Java developers who are right now upskilling in AI, and do drop a comment about what did you learn about AI engineering from this particular video or from this series, and would love to read your comments about any feedback or questions that you have. Thank you so much for watching.